Okay, Assalamualaikum. This video is a discussion for chapter 4, continue for tutorial 4B. Okay, so the first question, draw the restructure for the following compounds and use the Vesper theory to predict the molecular shape. Okay, first is H2O. As you know, you must first draw the Lewis structure. Okay, for oxygen 6 valence electron, hydrogen 1 times 2. So and then draw the Lewis structure. Okay, so bonding between oxygen and hydrogen to 4 and the lone pair, okay, on oxygen. Okay, and then to determine the molecular geometry or shape, first you must determine the bonded atom, how many bonded atom towards central atom, or we call as bonding pair. And then is there any lone pair on central atom? Okay, focus on central atom. Is there any lone pair? Okay, so here there are 2 atoms bonded towards central atom or 2 bonding pair, and then there's a 2 lone pair on central atom. Okay, so how you want to predict the geometry? So basically, if total here is 4, if all is atom bonded towards central atom is tetrahedral, but now there's lone pair, 2 lone pair on central atom, so the structure distorted, becoming band structure. Okay, and then you must if given in Vesper theory, you must draw based on Vesper theory. Okay, this is the shape is band. Okay, first draw Lewis structure, determine how many bonding pairs or how many atoms bonded towards central atom, and then is there any lone pair on central atom. Okay, and then determine the geometry. Next, for ammonia Nh3, so nitrogen 5 valence electron, hydrogen 1 valence electron times 3 atom hydrogen, so total 8 valence electron. Okay, first draw the Lewis structure. Okay, so 1, 2, 3 bonding pair between hydrogen atom and nitrogen. So 6 bonding electron. 8 minus 6 is 2. So left 2 non-bonding or lone pair, 1 lone pair on nitrogen atom. And then you determine how many bonded atom towards central atom. Okay, so 1, 2, 3. 3 bonding pair or 3 atoms hydrogen bonded towards nitrogen, okay, which is central atom. Is there any lone pair on central atom? Yes, there 1 lone pair, right? Okay, so basically if all is atom bonded to nitrogen, total kat sini 4, kalau semuanya adalah atom, bentuk dia tetrahedral. But now only 3 atoms here bonded to central, and the central atom has lone pair. So the structure is what? Trigonal pyramidal. Okay, ada 3 tapak kat sini. Tapaknya adalah trigonal dengan atas ni membentuk forming one pyramid. Okay, so if we want to draw based on Vesper theory. You must draw for geometry trigonal pyramidal. Okay, with the angle. So the molecular geometry is trigonal pyramidal. Okay, base-nya tapaknya adalah trigonal. Okay, 3 dengan 1 atas bentuk piramid. Okay, next. Okay, next is tin 2 chloride. Okay. Okay, so tin group 14. So 4 valence electron, chlorine group 17, 7 valence electron times 2 atom chlorine. So 14 altogether is 18 valence electron. Okay, so tin is the central atom, bonded atom, chlorine. Okay, so there are 4 bonding electron here. So left is 14. 1, 2, 3, 4, 5, 6, 7. So 6 non-bonding electron on each atom, chlorine. Okay. So and then left 2 non-bonding electron and we put on central atom. Okay. 18 after we minus with bonding electron 4, so 14, and then 12 on both chlorine atom, left 2 on central atom. Okay, so these are the Lewis structure. And then how to determine the geometry? So look at how many atoms bonded to central or how many bonding pairs. So there are 2 bonding pairs or 2 atoms, chlorine bonded to central atom, and then is there any lone pair on central atom? Yes, there's 1 lone pair on central atom. So okay, you do no need to remember, okay, but you just know and understand if there's all atoms bonding here, if all atoms bonded is 3, this is a trigonal planar. But now on central atom is lone pair and not the atom, and there's 2 atoms bonded to the central atom. So the shape now is started to band structure. Okay, so if you draw on based on Vesper theory, you must draw based on its angle for band. Okay, and there's 1 lone pair. So the geometry is band. Okay, next question, number 7. Draw Lewis structure and give information for the question. Okay, for A, sulfur trioxide, SO3, polar or non-polar molecule. Okay, first you have to draw the Lewis structure. Okay, sulfur group 16, the valence electron is 6. Oxygen 6 valence electron also, times 3. So all 24 valence electron, and then draw Lewis structure. Okay. Okay, so 246 valence 18 for the for the non-bonding electron. Okay, so when we look at the octet, sulfur not achieved, so we make a double bond here. Okay, 2, 4, 6, 8. Okay, so actually sulfur can become expanded octet. Okay, so if you have possibility to form restructure. Okay, for example, when we put here as double bond, okay, and then you calculate the formal charge. Okay, so this one also can forming a double bond here. Okay, so you choose the lowest formal charge and then use that restructure for your molecule. Okay, for example, sulfur here 6 valence electron minus electron assigned to it. So 1, 2, 3, 4, 5, 6. Okay, 6 minus 6, 0. Oxygen 6 valence electron minus electron assigned to it. 1, 2, 3, 4, 5, 6. Okay, sharing electron. 1 sharing electron, you calculate A plus the lone pair. Okay, so same with this one, 0 formal charge, 0 formal charge. Okay, if you look this structure, 6 minus 1, 2, 3, 4, 5. Okay, so plus 1. This oxygen, 6 minus 1, 2, 3, 4, 5, 6, 7, negative 1. Here, 6 minus 1, 2, 3, 4, 5, 6. Okay. This structure, sulfur 6 minus 1, 2, 3, 4. So the plus 2. Here 0 formal charge, 0 formal charge. This one 6 minus 7 minus 1. So the most plausible, the most likely Lewis structure, you would choose 0 formal charge, the lowest 0 formal charge. Okay. So these are the structure. Okay. So we look to know non-polar or polar. First, you draw Lewis structure, okay, and then by the geometry, and then you can look at the polarity. Okay, so to know the geometry, you look at how many bonded atom or how many bonding pairs, and is there any lone pair on central atom. So there are 3 bonding pairs, okay, or 3 bonded atom towards central atom, no lone pair on central atom. Okay, so the geometry is if 3 bonding pairs, okay, is trigonal planar. Okay, trigonal planar. So when we draw based on Vesper theory, you must draw based on geometry trigonal planar. Okay. Okay, so and then to know the polarity, you look at the dipole moment, either can cancel or cannot cancel to each other. So when you look between sulfur and oxygen, which one is the electronegativity atom? So oxygen is the electronegativity atom, and then the the arrow of the dipole moment, okay, means that here is the electron sharing between sulfur and oxygen. So the arrow means that the electron will attracted towards electronegativity atom. So between sulfur and oxygen, electron here will attracted more towards oxygen. Okay, so semua ke arah oxygen, the resultant dipole moment pada structure ataupun geometri yang symmetrical dan ada dipole moment pada in one plane ke arah luar. So the resultant is zero dipole moment. Okay, so maksudnya dipole moment can cancel each other. Okay, so jadi zero dipole moment, and then the molecule is non-polar. Okay, in one plane, and then the resultant dipole moment ke arah keluar. So zero dipole moment, the molecule SO3 is non-polar. Okay, for phosphorus trifluoride. Okay, first draw Lewis structure. Okay, total 26, and then we draw Lewis structure. Okay, 26 minus 6 bonding electron, so there are 20. Okay, 20 non-bonding electron. Okay, so here we put the electron on fluorine. So there are 18, and then balance to non-bonding electron we put on phosphorus as a lone pair. Okay, so this is Lewis structure. Next, to know geometry, you have to know the electron group geometry. Means that how many atoms bonded to a central atom, or how many bonding pairs. So there are 3 bonding pairs here. Okay, and then is there any lone pair on central atom? Yes, there's one lone pair on central atom. Okay, so how to determine the polarity? So you kena tengok dulu geometry. Okay, tak perlu hafal sini. So actually there are total 4 kalau semuanya atom yang bonded pada central. Kalau 4 dia adalah tetrahedral. Tapi sekarang ni satu adalah lone pair. Okay, pada central atom 3 bonding pairs atau 3 atom bonded kepada central and 1 lone pair. So actually the geometry is, okay, kalau nak lukis based on Vesper, kena lukis based on angle untuk structure tu. So ini adalah trigonal pyramidal. Okay, base-nya tapak dia trigonal, atas forming one pyramid. So dia adalah geometry trigonal pyramidal, one pyramid above. Okay, and then either the molecule polar or non-polar. Okay, we look at the dipole moment, either can cancel or cannot cancel each other. Okay, so between phosphorus and fluorine, okay, kita tengok daripada electronegativity of its atom. Okay, so fluorine more electronegativity than phosphorus, so the dipole moment, the arrow go to fluorine. Okay, maksudnya electron pada bonding akan tertarik, okay, attracted more towards fluorine compared to phosphorus. Okay, dia lebih tertarik pada fluorine, so arrownya towards fluorine. Okay, so the structure is not symmetry, and the dipole moment more go towards atom fluorine. So the dipole moment now cannot cancel each other. Okay, actually setiap dipole moment ni dia ada value ya. Okay, so bila cannot cancel each other, dia masih ada value lah maksudnya is not zero. Okay, so the molecule is polar. Okay, bila dipole moment cannot cancel each other, there's a value, the polarity of this molecule is polar. Okay, next question. So we look at this. Okay, so fluorine, silicon and atom hydrogen. Okay, total in this molecule valence electron is 26. Okay, so we draw Lewis structure. Silicon as central atom because the electropositivity of the atom. 3 atom fluorine and 1 hydrogen. So make the bonding 2, 4, 6, 8. So valence is 18. And then this 18 is non-bonding electron. So we draw non-bonding electron on fluorine. Okay, so each fluorine has 6 non-bonding electron. Okay, 6 times 3 is 18. So there's no more left non-bonding electron. So this is Lewis structure for this molecule. Okay, and then to know the direction of dipole moment, you have to draw based on geometry shape first. Okay, so what is the geometry? We look at the the bonding pairs. Okay, how many atoms bonded towards central atom? So there are 4 atom bonded, okay, or 4 bonding pairs, and there's no lone pair on central. Untuk tentukan geometri, kita fokus lone pair pada central atom saja. Okay, dengan berapa atom yang bonded towards central atom. Okay, or how many bonding pairs. So the geometry is 1, 2, 3, 4. All atom bonded, okay, towards silicon. So the geometry is tetrahedral. Okay. Before you want to know polarity, you have to know geometry. Before you want to know geometry, you have to know the how many bonded atom and lone pair on central atom. Before that, Lewis structure. So the direction dipole moment, okay, we look for you look one by one, okay, for determine the dipole moment for each bonding. So between silicon and fluorine, fluorine is more electronegativity, so it will attract more electron share here. Okay, here's one by one the bonding between silicon and fluorine. Fluorine is high electronegativity compared to silicon, so electron will more attracted towards fluorine. Okay, this one is also same towards fluorine. For bonding between silicon and hydrogen here, okay, silicon more electronegativity towards more electronegativity compared to hydrogen. So the electron share here will attracted more towards silicon. Okay, so this is the resulted dipole moment. Okay, kalau nak tengok polarity, the dipole moment can cancel or cannot cancel. The dipole moment will determine the polarity. So in this case, this molecule, the dipole moment cannot cancel each other. Okay. Even the shape is symmetric. Okay, we look at the arrow of dipole moment. 3 is towards outside, okay, ke arah fluorine, and one arrow towards silicon. Okay, so it cannot cancel each other. If this arrow towards outside, so it can cancel each other, the dipole moment is 0. Okay, but now the dipole moment has value, so cannot cancel each other. Okay, the vector is the different direction. Okay, so this molecule is polar. Okay, dia adalah polar. Next. Okay, for this cyanide ion, so we calculate the total valence electron. Okay, remember this is ion at an ion, so additional 1 valence electron. Okay, total is 8. So we draw valence, we draw restructure. 2, 4, 6. 8 minus 6 is 2. 2 non-bonding electron on silicon. Okay, hydrogen, there's 1 electron only has been shared already. Okay. So in bracket because it is this ion. And then to know the geometry, we look at the bonding pair or how many bonded atoms. So there are 1, 2, 3 bonding pairs or 3 bonded atoms towards central atom. And then is there any lone pair on central atom? Yes, focus on central. There's 1 lone pair. So the geometry for this ion. Okay, so actually if 4 atoms fully bonded to central is tetrahedral, but now 1 being as a lone pair on central atom. Okay, and then 3 bonded atoms. So the geometry, draw based on this theory. Okay, the geometry is trigonal pyramidal. Okay, trigonal pyramidal. So either planar or pyramidal shape. This is pyramidal shape. Okay, trigonal pyramidal. Okay, check your answer. Okay, so if you know the geometry, you can know the polarity. Okay, so if you know the polar or non-polar, you can know the intermolecular forces. So we look at the polarity. So either this molecule polar or non-polar. Okay, so between we look at the each bonding. Okay, so ini adalah bond polar bond. Okay, so kita tengok satu-satu. Tak bermaksud walaupun dia ada polar bond, molekul tu polar or non-polar. But we depends on the dipole moment. Either it can cancel or cannot cancel each other. So silicon more electronegativity than hydrogen. Electron share are more attracted towards silicon. Okay, so thus the geometry is not symmetrical and the dipole moment all towards silicon. So it cannot cancel each other. So it has value. So the ion is polar. Okay, because dipole moment cannot cancel each other. Okay, next question. Which member of each following pairs of substance expect to have higher boiling point? Okay, so for A, oxygen and chlorine. Okay, so how to know the molecule has high boiling point or not? Okay, we depends on the intermolecular forces. Okay, intermolecular forces. Okay, you learn in chapter 4 the highest, the strongest is a hydrogen bond. Okay, so it has higher boiling point because difficult to break the bonding between the molecules. Intermolecular forces is the forces between the molecules. Okay, so but we can look at that one molecule, so we can know the intermolecular forces by knowing either the molecule polar or non-polar. Okay, so for first in oxygen and chlorine molecules. Okay, so either this molecule polar or non-polar. Okay, both the molecule is non-polar molecule. Okay, because the electron share are equally, so the bonding between oxygen molecule and chlorine molecule, okay, so is London dispersion forces. Check your answer. London dispersion forces for both, okay, because non-polar molecule. Okay, for that one for A. For B, between sulfur dioxide and carbon dioxide. Okay, before that, you have to know the polarity of the molecule. Okay, how to know the polarity? Actually, previously you have to know the geometry. Okay, so dia berkait. First restructure, yang tadi restructure, lepas tu geometry, number 2. Okay, number 3 either polar or non-polar, and then number 4 you can know the intermolecular forces. Okay, for sulfur dioxide, you have to know the polar or non-polar. So the geometry for sulfur dioxide. So actually, sulfur dioxide, when you do the Lewis structure, you will get, okay, this is the Lewis structure for sulfur dioxide. So geometry for sulfur dioxide is 2 bonding pairs, 1 lone pair. 2 bonding pairs, 1 lone pair. So what is the structure? Okay. So this is band. Okay, so we look at the either polar or non-polar this molecule. So oxygen more attract more electron towards oxygen compared to sulfur. Okay, and then this molecule is polar because the dipole moment cannot cancel each other. So polar. And then for carbon dioxide, we compare. Okay, so oxygen attracted electron more towards oxygen compared to carbon. Okay, so this is polar bond between carbon and oxygen. But either the molecule polar or non-polar, you look at the dipole moment. So the vector is a different ways, or it can cancel each other, the dipole moment. So carbon dioxide is non-polar. Okay, before that, this one is linear. So we do the dipole moment direction to know the molecule polar or non-polar. So if the you know the interaction intermolecular forces between carbon dioxide molecule, if non-polar, it has only one forces, which is London dispersion forces for carbon dioxide. Okay, for sulfur dioxide, polar. So what is intermolecular forces between sulfur dioxide molecule? Okay, interaction antara sulfur dioxide and lain, what is intermolecular forces? So okay, so this is polar molecules. So the intermolecular forces is it has dipole-dipole forces. Okay, for polar it has two actually, London dispersion forces and dipole-dipole forces. So dipole-dipole is a bit stronger forces compared to London. Okay, so next comparison for C. Okay, between HF and HI. Okay, how to know the intermolecular forces? You must know either this molecule polar or non-polar. So this simple molecule so has a bond, polar bond. Both are polar. Okay, both are polar. So what intermolecular forces exist? Okay, for HF, if polar, either dipole-dipole or hydrogen bond. So remember hydrogen bond, hydrogen and the interaction between fluorine, oxygen and nitrogen. So this is the forces between hydrogen fluoride molecule is hydrogen bond. Okay, hydrogen bond. And then Hi is not hydrogen bond, so just dipole. Okay, dia akan membentuk permanent dipole dengan hydrogen this molecule between Hi molecule. So it has dipole-dipole forces. Okay, all polar molecule has London dispersion forces, but if polar either other than hydrogen attached with FON. Okay, other than that is dipole-dipole. So, which pairing has a highest boiling point is C, okay, between HF and HI, because hydrogen fluoride, hydrogen bond, intermolecular forces, and HI is dipole-dipole forces, okay, the strongest pairing. If for B, okay, for B, sulfur dioxide is has dipole-dipole, while for carbon dioxide London dispersion forces. Okay, for A pairing, both are London dispersion forces. So the members that has a higher boiling point is hydrogen fluoride and the pairing for C. Okay, hydrogen bond and dipole-dipole. Okay, that's all for tutorial for B.